Good day to all. Today we can discuss about a problem in an integrator in the subject linear integrator circuits. So the problem is consider a lossy integrator circuit shown in figure for the component values of R1 equal to 10 kilo ohm, RF equal to 100 kilo ohm, CF equal to 10 nanofarad. Determine the lower frequency limit of integration and study the response for the input, sine wave, step input, and square wave. So first we can determine the lower frequency limit. So how to determine the lower frequency limit is, so the lower frequency limit is given by Fa is equal to 1 by 2 pi RF CF. RF is given and CF is given. So now directly we can able to calculate Fa. So RF is 100K and CF is 10 nanofarad. So it is 10 into 10 power minus 9. So it becomes 10 into 10 power minus 9 and 100K. So 100 into 10 power 3, you will be getting 159 hertz. So for accurate integration, the input frequency must be at least 1 decade above FA, that is 1500, the 159 hertz. Okay. So for the next is for the sine wave input. So for the sine wave input, generally for an integrator, you know the output is V naught of t equal to 1 minus 1 by R1 CF, the integration of VI of t dt. V R1 is given, it is 10 kilo ohm. What is VI of t? So they have given peak sine wave of 5 kilohertz. The output V naught you have to calculate and the input is 1 volt. That means it is 1 into sine 2 pi into 5 kilohertz, so 5000 T. General expression is A sine 2 pi F T. So here F is 5 kilohertz and A is 1 volt. So you are going to substitute 1 sine 2 pi. So when integrating this, you will be getting the value should be integration of sine is minus cos 2 pi 5000 T divided by 2 pi 5000 and 1 by R of C1 already we have calculated, it is 10 power 4. So you'll be getting 0.318 cos 2 pi. That is, if you are giving a sine wave input, it will be integrated to a cosine signal and the output is a cosine wave with a peak amplitude of 0.318 volts. What is the amplitude? It is 0.31 volt. The frequency should be for the same thing, 5, that is 5000 T. Second, we can see the diagram lastly. And second is the step input. Step input, it is given with the input should be of VA is equal to 1 volt. Then the output voltage T. How it will be? T is because it can be seen that input of constant amplitude of 1 volt ranges from 0 to approximately equal to 0.3 milliseconds and minus 1 volt. If it is as a minus 1 volt, then it should be ranging between 0.3 milliseconds to 0.4 milliseconds. Sorry, 0.5 milliseconds, 6 milliseconds. The output for this is, so we are going to integrate between 0 to 0.3 milliseconds. And it is between 0 to 0.3 milliseconds. How should be it is evaluated is 1 by R1 CF, you know. If we are integrating that, they will be getting T. The T value is 0.3 milliseconds. So directly we can substitute over here. You'll be getting around minus 3 volt. The output voltage is a ramp function with a slope of 10 volt per milliseconds. So how it will be like this, where by seeing the diagram, I will explain you. Then for this square wave input, the output waveform for an input of 5 kilohertz, that can be as we know that for a square wave input, it will be treated as a signum function, and in the input is a constant amplitude of 1 volt from 0 to 0.1 milliseconds and minus 1 volt from 0.1 milliseconds to 0.2 milliseconds. The output for this will be so ranging between only 0.1 milliseconds. So it is almost it is equal to minus 1 volt. This represents the total change in the output voltage over the first half cycle from 0 to zero point 0.1 milliseconds. So see the diagram. You are giving a sinusoidal input, you'll be getting a cosine signal input. And for a square wave input, it will be integrated as up to 0.1 milliseconds. And then it will be ranging from zero point 0.1 to zero point 0.2 milliseconds. The output for each of these half periods will be ramp as seen from the step input. And now for the this input, you will be getting here should be a since we are giving 1 volt here, we will be getting a minus 3 volt at up to minus 0.3 milliseconds. So this is the way you will be getting the output for an integrator. Hope it will be understand. Thank you.